In last week's video I made this collet block and of course also the nut that goes with it. And to use this thing I need my decal collets. Now there's absolutely nothing wrong with these collets, it's just that they have a buttress thread. That's all. But I would like to comment on some comments that you left in the comment section. Comment section, of course. In this video we can see that at one given moment I stop cutting the thread in this nut because I had the wrong cutting tool. Now if you haven't seen that video, there's a link below in the description, okay? So no problem. I made a cutting tool that cuts this thread and I needed a cutting tool in the other direction. Now, of course, some pointed out the cutting tool to cut this thread is perfectly fine. And indeed, it is. There's just one little problem. Let's imagine for a moment, and I'm sure you can do this, that this is the chuck of the lathe and this is the nut I have to cut. And this thing is in here. And with my cutting tool I'm gonna cut the thread, and then if I want to do a test fit, of course it will never fit because the shape of the thread is in the wrong way. To be good I should test fit in this direction, but there's something in the way here. So what I had to do was to change tools, and of course my nut was in this direction in the chuck, and in this side it fits perfectly fine. So now I hope that it makes a little bit more sense that cutting this thread in this direction could work, but you cannot test fit. And that's why I made a new tool to cut the thread in the other direction. Test fit possible. Now I believe that doing a test fit on a thread you cut is always a very good idea. Because if this is all material and we are cutting this side of the thread, on the drawing it is a point. In reality it is not. There is a little radius in here, or a flat, or most of the time radius. And we're gonna make a cutting tool. It is of course a form tool at 5 degrees and 45 degrees. What I did, I fed in at 45 degrees, and the radius here on the tip of the tool is, nobody knows. This is close to impossible to measure with the things I have here to take measurements. So it's always a little bit a guess. And the calculations depth I don't remember anymore, at 45 degrees. If we take a round number instead of point something something something, there will always be a difference. So just to be sure that it works, test fit, make new cutting tool, that's all. And now talking about cutting tool, here it is. And the way I made it could maybe look a little bit like a real challenge, but it isn't. Let me show you. To make carbide or very small high-speed steel cutting tools, I use my diamond cup wheel here on the milling machine. And to show you how it works, first let me start with a very easy 60-degree cutting tool to make threads. Now, most home, kitchen and garden threads are 60 degrees. Now, I'm not gonna make a real cutting tool because I don't need one. I have 2 or 3, but I will show on this thing. This is of course also 60 degrees, and just imagine it is high-speed steel, for example, right? So of course we will install the thing in a vise, for example, like this. No. Yes. I'm pretty sure there's a lot of people out there that have these fancy angle blocks and all this kind of stuff. As you can see, I don't, and I don't need. I suppose you already understood that we will cut this side of the cutting tool. And because my diamond cup wheel is spinning that way, we will grind with this side. So the burrs and all this other shit that will be formed will be pushed downwards, down in relationship to the cutting side of the tool. This side is of course the top side. But because this side of my cutting tool will also need free space behind the cut, what we call, I think, the relief, all we do is install the vise at, for example, 4 degrees. The 4-degree angle for the tools I make work very well. And then of course install one side. I can just use the T-nut and a stud. 4 degrees. I cannot use a T-nut and a stud, so I install a clamp and I'm ready to grind one side. And of course, when I grind something, I always use my good old Electrolux to suck the dust. This side of the tool is now finished and we have to do the other side. The easiest way could be, of course, to install it here and go to the other side of the cup wheel and then start grinding. But because of the spinning direction of the cup wheel, this side will form a burr. And this is why I like cup wheels, because I will install my tool not at 60 degrees but at 30 degrees, this way, and then use the bottom side of the grinding stone wheel cup diamonds thing here. And now you're gonna say, but Stefan, Rusty, if I grind this top surface with this bottom surface of the cup, I will not have a relief angle, and putting my vise in whatever angle, okay, stud, move it, in whatever angle, of course doesn't change a thing. So it's impossible. Impossible. 2 big parallels. Lift the vise, put this thing under here, put it down, check the angle, 4 degrees, perfect. Tighten these nuts here, grind, Bob's your uncle. As you can see, making thread cutting tools, not really a problem. Internal and external cutting tool for butter thread, both made exactly the same way. As you can see, it's perfectly possible. Some people also wrote in the comments that now that I have a hex block, I should also make a square block. I don't think so. If you have a hex one, you don't need a square one. If, for example, you have to make 2 flats for a spanner. Yeah? Now, not this one, because this one is way too big to fit in my collet, but just to have an idea. I put my part in here, cut 1 flat, take the Olswig out, rotate 180, put it back in, cut the other side. Result, 2 flats. That's all. If I need to make flats on a bigger part, like this one, put it in a vise, cut a flat, rotate 180, and then it's very easy to check if it's aligned with, for example, adjustable parallels that are in better shape than mine here. But let's try something, for example with this one. Let's cut a square. Cut one side, rotate 180, put it parallel, cut the other side. No problem at all. Even more easier-ish. Cut one flat, rotate 90. Take a little square, put it square, cut a flat, put it square the other side, cut it flat. Now we have already 3 sides, and then of course the 4th side exactly the same. No need of colored block. A few videos ago I made keys for this kind of locks for the tram, railway, road, and as you can see they work perfectly fine. So the tram guys, they are very happy with them. But I am not so happy with them, because they look a bit like shit. The problem is of course the heat of the welding makes this ugly discoloration. And that's what I told the tram people. But they say they don't care. But I do. I am convinced we can do better. And that's why I made 4 more. And I recycled this very nice little chromed studs. I think this is 4.5 millimeter or something. And this is normally used in a kitchen sink. And as you can see, I have a nice little collection here. Now, what I would like to try is to use this, of course, through the hole, and then cut a piece off, a very nice and easy length to use, and make 2 little balls, which means I need to cut a thread on this side and on this side. And I think it will look good if I use, for example, brass. This thing used to be a part of the old barge I used to work on. The barge doesn't exist anymore, but it will still continue to live in the pockets of the tram people. Of course, in ball form, not in barge form. But whatever. I cut off 2 little pieces of these studs. And these are somewhere between 4.8 and 4.9 millimeter. So I'm gonna cut a metric 5 thread on both sides. And the easiest way to do this is of course to use a M5 die that I don't have. So I will do it here on the USSR lathe. And this is where I have to change my plans a little bit. To cut a M5 thread on here, it needs a pitch of 0.8 millimeter. And to do so I need to install in this machine, on the back side of course, a change gear with 75 teeth that I don't have. Of course here on the Celtic I can install a pitch of 0.8 millimeter. The problem is that the movement is so fast, it is scary. As you can see, I installed my part in the chuck. And this is the 0 point where I have to start cutting the thread. And the thread will stop 10 millimeter further, right here. Here I am so close to the chuck. This is really stressful. And I think machining must be fun and not stress. So what I think I'm gonna do is first make these little bolts out of this thing here and then drill a hole 5 millimeter, and then these little studs, pins, things here, put them inside, and on the other side of the ball I will pin them over a little bit like a rivet. Maybe that could work. My little part is now turned to size and I drilled a 5 millimeter hole. And I also made 2 form tools that together should in theory form a ball. Let's see if it works. This tool doesn't work very well. It will cut off the ball before it is completely formed. So that's not good. So I will cheat a bit and give it a touch of final. I installed my second tool in an angle almost 45 degrees and this worked much better. I have 2 little balls. The problem is they don't have the same size. So I started working on a third one, and this is where the tool climbed on the workpiece, and here's the result. The thing is completely bent and it broke. And of course this is the kind of little accidents that happens when the camera is not recording, so no footage. Right, let's see if it's possible to assemble this thing without causing more damage. I think I'm gonna flatten this a little bit to have a tight fit here, and then with my center punch try to open it up. Let's see. As you could see, I didn't use the center punch because I believe that the little heads here will look better without this little pit in here. Now, as you can see, the thing works, but only half. That's not enough. And second problem is that this little stud here, while hammering on it, now it is bent. That's not good. Second plan. Let's make a new little bar, but turn down the ends and then install the ball here so it can go further this way. And then of course this will be longer. Make a little chamfer here and then pin it over. This will work much better. And now for the second option. One of the railroad guys, he would like to have a key, of course like this one, but with a ring so he can hold it to use it, and also use it as a key fob or to put it on a key fob. And I have a whole collection of this kind of hooks that normally you use in masonry. And I think this is very nice and solid steel. This will work. I think this will be a little bit too small, ring too small. So I started again with a bigger pipe, and after a touch of angle grinder, they look now like this. The trick is now to have this thing in here. And after a little bit of hammering to straighten it out, they look like this. And I think this will be just fine. So as you can see, doing a little bit of experimenting can be very useful. Option 1 works perfectly fine and everybody's happy with them, but it looks like shit. Option 2 is a lot of work, and if the little balls are not exactly the same, it also looks like shit. So now I think I found the easy solution. This is really quick and really easy. First I thought maybe I should weld this ring, but this steel is so hard, so tough, it doesn't move. In my opinion, this will work very well.